All right, let's take a look. Hello, my name is Alan Ho. I am a VP of AI for DataStax. I handle both our AI strategy as well as our research program at DataStax for AI. And I am very happy to welcome the one of the pioneers of Retrieval Augmented Generation. So Douwe, do you mind kind of introducing yourself and tell us a little bit about yourself?
Sure, yeah. So how you actually pronounce my name is Douwe, as in Dow Jones.
Oh, sorry.
Or if you want to do it the Dutch way, Douwe. Yeah, I'm from Holland originally. I'm CEO at Contextual AI. We're building the next generation of language models. I'm also an adjunct professor at Stanford. Before this, I was the head of research at Hugging Face. And before that, I spent a bit over 5 years at FAIR, Facebook AI Research.
Great. So, tell us a little bit about how you got into AI, a little bit about your background, and yeah, like what was your journey? What was your journey like?
Sure. Yeah, it was a fun journey. It was very unusual, actually. So I started off as a philosopher. The reasoning behind that is in high school, I was kind of a script kiddie. I taught myself to code, so I thought I already knew everything there was to know about computers. I was very wrong, of course. So I figured I wanted to study something else instead of computer science. So I ended up studying philosophy with a focus on philosophy of the mind, philosophy of language, did a bunch of cognitive science, did a bunch of cognitive AI, I guess you would call it. After that, figured I was very interested in logic. So I did a degree in logic at the IOLC in Amsterdam, one of the most famous kind of logic institutes doing foundations of math. And then I figured I needed a real job. So I ended up studying computer science after all. So I did a PhD at the University of Cambridge. And so during that PhD, I did an amazing internship at Microsoft Research. With Leon Bottou, one of the kind of godfathers of AI, the inventor of stochastic gradient descent and things like that. And that internship went very well. So when I graduated, Leon had joined FAIR with his longtime collaborator, Jan LeCun. And so I figured that would be a fun place to join as well. So that's how I ended up kind of at FAIR.
Wow. Okay. That's, talking about, I can relate because I studied physics and I realized I needed a real job too. So first job out of school was doing machine learning for semiconductor process control. Okay. So tell us a little bit about kind of retrieval augmented. I'm going to assume that a lot of people here know about retrieval augmented generation. So tell us a little bit about where did the idea come from, and tell us a little bit of the origins of it.
Sure, yeah. So first of all, like this is not really my idea, right? As it happens with these kinds of ideas, you can't really take sole credit for anything like it. So there were a bunch of people involved, and if you look at the paper, there were like Patrick Lewis, Ethan Perez, Sebastian Riedel, all of these folks. They deserve just as much credit, if not more, than I do. But where the idea comes from originally was I was working with Ethan Perez, who was my PhD student at NYU, and he had come to intern at FAIR a few times. And we were thinking about grounding basically in evidence. And so if you want to do grounding, so meaning basically comes from your ability to ground concepts in other concepts, right? So if you can find generalizable evidence and give it to a language model, at the time we weren't really talking about language models yet, but like sequence to sequence models, for example, then it can generate based on the evidence that it found. So we were very interested in trying to do that. And did some preliminary projects on that also with like Jason Weston and Kyung-Yeon Cho and people like that. And then we were trying to scale that up basically to a much more general system that wasn't just doing question answering, but that would have access to like a Wikipedia index basically, and then have this external memory where you could do retrieval over Wikipedia and then answer any question. So really open domain question answering. But Ethan, unfortunately, had to go back to NYU because he wasn't allowed to stay at FAIR anymore. So the project kind of was at risk of sort of dying prematurely. And I spent some time at FAIR London, where they had done some amazing work in this space already, open domain question answering specifically. So started talking with Patrick Lewis and Sebastian and a bunch of other people, and then Patrick kind of took over as the sort of first author, implementer of a lot of the ideas, and he just did an incredible job. So out of that came this paper that had state of the art on a bunch of different open domain QA benchmarks, and so what's really funny to me actually is, so if you look at the paper now, all of these people are like rock stars, right? So they really changed a lot of stuff, I think, in what is now kind of mainstream. But this idea of RAG that is now mainstream, and as it's implemented in like LangChain and Llama Index and all of these different things, that's actually just a baseline in the paper. So if you go to the paper, and I think it's like table 6, it has a row in there about frozen representations. And so what the paper is all about is basically saying, if you don't freeze it, but if you actually backprop into at least a query encoder, then you can do much, much better. So that was the original idea behind the RAG implementation, is that you can have this retriever and this generative model work together and be jointly optimized, at least for a large part, to solve the problems that you're interested in.
And I'm just showing this for the people on the screen. This particular figure, is that correct?
Yeah. So basically here we have this query encoder, and so you can backprop into the query encoder. So you can keep all the documents fixed, but then you can backpropagate into the query encoder so that you can learn what you're looking for. And so what you actually want very often is not similarity necessarily, which is what a lot of people are using vector databases for now. What you want to have is relevance to whatever the input is, or whatever the prompt is to your language model. So in order to get better at that, you should try to optimize the retriever as well.
And so when they say that the generator, this in a sense is your LLM, and when you're backpropping it, you're training, you're changing the parameters as you're doing the backprop, right?
Yeah, that's right. Yeah. So they're coupled, right? And so if you scroll down here to table 6, then you can see that this approach works better than a bit further down table 6. This approach works much better than if you freeze everything. So there's this RAG token frozen and RAG sequence frozen. So RAG token is basically doing retrieval every token step, and RAG sequence is doing retrieval over the entire sequence. And you can see that if you actually do the full RAG, then that works much better than the frozen RAG.
And this is kind of interesting because most people haven't actually implemented. People are still doing frozen RAG, right? There's a lot of opportunity to even improve upon frozen RAG by if you allow this kind of like, in some sense, training, doing backprops to the entire model, correct?
Yeah, that's right. But so at the time, right, this is so the RAG project basically builds on 2 or 3 kind of separate contributions that happened at FAIR at the same time. So there was FACE, which is really incredible. It's like the foundation basically for all existing vector databases right now, I would say. So based on FACE, there was this dense passage retriever project, DPR, where they showed that you can do very good retrieval specifically for question answering when you want to find evidence. And then there's the BART model, which was kind of the successor of BERT, but it was trained in a sequence-to-sequence way so that you could condition it on some evidence, for example, and then you want to generate the answer. So if you combine all of those pieces, then you basically get this RAG architecture. At the time, we didn't have in-context learning yet, so that wasn't really a thing. Right? Yeah. So if you want to optimize these systems, then you have to actually optimize them. And so that's what we ended up doing. But I guess a bunch of people who strongly believe in context learning would argue that you can just give it to the context and let the language model figure it out. So that's what a lot of people are doing.
So has anybody actually, I mean, we've been hearing about GPT-4, GPT 3.5, and then Google has Palm 2, and very soon they're going to have this Project Gemini. Has anybody actually used this mechanism where you're backpropping through a knowledge base to build like a big model? And is that something that people are doing right now?
So I know that a lot of people are working on it, yeah. But I don't think any of the big language models are doing that right now. And so actually, like, doing this properly at scale is not trivial, right? So it kind of it sounds like an easy idea, but there's a reason that systems don't do it. So if you look at like Retro out of DeepMind, which is a retrieval augmented language model, they keep the retriever completely frozen. And that's because if you want to do this at scale, then you really need some technical expertise in doing this in a distributed setting.
So they keep the retriever frozen, but then the generator,
including the query encoder, right? So you have your document vectors, let's say like the internet or whatever is encoded in your vector database, and now you have this other encoder that's your query, so the thing that you're searching for. And so in Retro, both of these are fixed.
Oh, interesting. Okay, very cool. So tell us a little bit about Retro, and like maybe tell us like a little bit of how did that advance the state of the art?
Yeah, so there are two papers out of Google. I mean, Google has been doing a bunch of amazing work in this space too. But the original paper was Realm from Calvin Gu and others, and so. I was very frustrated when that paper came out, actually, because they scooped us, basically. We had the same idea, and we were like a month or two behind. But when I looked at Realm more closely, I saw that it was a mass language model. So it was basically a BERT-like architecture rather than a generative model, which is what you want to have, I think, to like embrace the full power of the architecture. So Realm was really an amazing contribution, I think. And then so Retro, so I honestly think Retro could have done a slightly better job giving credit to prior work, because a lot of those ideas had already been around. There's this really nice paper on KNN-LM where they have a very similar idea to Retro, but a slightly less good PR machine behind it. So I think the original idea of Retro is basically just doing language model, but with an external non-parametric memory. And you can do that with this frozen BERT encoder vector database. And this allows you to do pretty incredible things. But I don't think that Retro really was the first to show that you can do those incredible things. But I think there are a couple of really salient points that they demonstrate very nicely. And one of the main ones is that the Retro model can be a lot smaller than the equivalent performance full language model. Right? So normally a language model is sort of a parametric beast where you like cram all of this information inside it. It's like this compression mechanism. You compress like the internet into the weights of your language model. The Retro architecture, or the Retrieval Augmented Language Model architecture, basically says you don't have to compress all of that information directly. You can just use retrieval. And if you do that, you can have a language model that is 25 times as small and that still achieves the same performance. So it's much, much more efficient. And I think if you look at the trends right now in where we're going as an industry, everybody's starting to wake up to the fact that these language models are not cheap, right? And so the cost quality trade-off is really what matters the most here if you're thinking about actual enterprise deployments of the technology, right? So if you actually want to use it to make money, then you can't be paying $3 or $4 per query, like you're currently doing with some of the bigger frontier models. So getting to that right optimal point, that's really where we need to go. And so this kind of retrieval augmented architecture is one way to get there. Yeah,
and I just want to kind of give my philosophy on these kinds of models, right? And at a higher level, in my opinion, there's two ways to embody information and knowledge. You could either embody the knowledge explicitly, such as rows in a database, or you can encode the information implicitly, such as in the weights and the biases of a neural network. And just kind of like a human brain has that kind as well. We have a hippocampus where we have our memory system, and we have our prefrontal cortex, which is connected to our memory system, and the two work together. And a complete AI system, actually, if you want to get to human level AI or even rat level AI, you need to have both systems. And I think we're just on, it's interesting how everybody has been focused on this part, right? The big tech companies have been focusing just on this, but they never really thought about how do we make, how do you make a system that represents knowledge explicitly well integrated with the system that's implicitly. And so that's what I found very fascinating about retrieval augmented generation. And it's almost a philosophical change of how we do AI.
Yeah, I agree. Yeah. And so the underlying idea is basically that you want to do grounding, right? So you can't just say something, you have to ground that information in something else. So if you really take this to the extreme, you could have this large multimodal kind of knowledge store of all of your prior experiences, basically. And then you have this reasoning module that just sits on top and it doesn't really do all that much. So this is your language model. And it basically knows how to query all of the relevant information and how to synthesize the things it retrieves and turn it into something useful. So ideally, what you want to have is you want to cram almost all of the information into your retriever and make that just explicit, because we can do that in the modern era of like big data and cheap compute. And then you want to have a very lightweight thing on top that basically just reasons, and it can talk, it can speak English, but it doesn't have any facts because they all come from the knowledge store.
So let's talk about retrievers, because I think that kind of shocked me. I've been working on, I used K-nearest neighbor like in the mid 2000s, and honestly I thought it was a pretty terrible algorithm. It wasn't very it was extremely sensitive to outliers, and I didn't really like it a whole lot, but at that time, we didn't have neural networks and things of that sort. So tell us, why do you think these kinds of K-nearest near algorithms are being used today? And is there something more popular? Or, I'm sorry, is there something better? Is there a better way to do retrieval other than K-nearest neighbor?
I mean, K-nearest neighbor is basically just saying that you specify some distance metric and then you find the K nearest points, and you can do a couple of tricks there. But so the real question isn't really about the similarity metric or the distance metric, it's about the representation. Right. So what has happened over the past 10, 20 years is that we've gotten incredible at representation learning. And if you have very good representations and you know how to do sort of approximate nearest neighbor search over huge amounts of data, then you can use all of these neighbors to do interesting things. So they're not K&N classifiers, right? Because that's a slightly different idea where you're trying to kind of collapse your class space onto the representations that you have, onto the embedding space. So what you can do is have something that works on top of your nearest neighbor algorithm and uses the information to inform predictions it makes. So this could be like completing the sentence or predicting the answer or whatever.
So when you say representations, you're really talking about the embeddings, the being able to semantically do embeddings. And tell us a little bit about that, because it seems like there's been some major advancements in the last 2 years that has popularized retrieval augmented generation. Can you tell us a little bit about representation learning and embeddings, and how has that been evolving the last couple of years?
Yeah, it's interesting you say that, actually, because I don't think I agree that there's been a lot of progress in representation learning recently.
Okay, all right.
I think a lot of these ideas, they just come from the original kind of word-to-vec and things like that. And then when word-to-vec was a thing, everybody in NLP was thinking like, okay, how do we get that to extend to sentences rather than words? So there was this whole, like around 2016, A lot of work was done on sentence representations. And then I think basically, so BERT happened, and then BERT just became the default sentence representation. And so what still surprises me to this day, actually, is that BERT is still by far the most downloaded model on Hugging Face. But you can just like add 2 letters or 3 and turn it into DBERTA when you load the model instead of BERT, and then your performance is going to go up by like 10 to 20%. So there have been advances, but even DBERTA is already a couple of years old too, I think. So in terms of like raw embedding capabilities, I think we've kind of like plateaued off a little bit since like all the kind of cool stuff that was happening initially around BERT.
Okay, well, this is a good transition into the next question. So what's the future of retrieval augmented generation? Tell us what you think is going to happen, and tell us what you think is going to happen overall, and then tell us more specifically about your startup and what you guys are going to be doing to push the leading edge.
Yeah, so what's going to happen, I think, is that really we are only just getting started with a lot of this stuff. And I think there's this whole general trend around augmented language models. So you don't have to necessarily just augment them with a retriever. You can augment them with tools. You can augment them with computer vision pipelines. We did this lens paper at Contextual where we showed that you can just take a computer vision pipeline, give the outputs to language models, and then make the language model vision augmented without doing anything fancy. So I think within that general trend, the next obvious step is to try to optimize. And so, like we were saying at the beginning here, a lot of the retrievers are frozen for computational reasons. But if you can solve these computational problems by just being a bit smart how you do distributed training, then you open up this much better architecture, like we show in table 6 of the RAG paper. And so that's just updating the query encoder. In theory, you should be able to update the document encoder as well. And so that's going to open up a whole bunch of different possibilities where you get these language models to generalize to all kinds of new data sources on the fly, where you can train the model in different ways to make sure that it can generalize even to different modalities. And so have a much more flexible system where the language model is just one small part, and you don't actually want your language model to be too smart because then it's going to hallucinate. You want your language model to defer to the things it has to rely on to do its job.
Oh, it's like human beings. You want to rely on facts rather than the bullshit that you come up with the first thing you say come out of your mouth, right? So yeah.
But I mean, so human beings are also very imperfect when it comes to that, right? But so that's basically what we're building with this company, right? So we think at Contextual that language models are amazing first generation technology. This stuff is really going to change the world. It's going to change the way that we do work. It's going to change our entire lives. In the future, everybody is going to be a CEO of their own little company of AI agents who are doing amazing things for them so that they can focus on sort of higher level strategic things. So in order to unlock that potential, we have to overcome a bunch of the hurdles that exist right now for enterprise adoption of this technology. And these are very familiar problems like hallucination and attribution, stillness, compliance, data privacy, the cost-quality trade-off we talked about. So if you can solve all of these problems, then the technology is really ready for enterprise adoption. And I think OpenAI and Anthropic and a bunch of these other places are kind of trying to bolt on solutions with like RLHF or constitutional AI or however you want to solve those problems. And what we're saying is like, let's go back to some of these older ideas around retrieval augmented end-to-end optimized systems, and let's just build a better language model.
So just to give everybody kind of a sense of this, what people are doing right now is they're taking a lot of PDFs and they're putting it into their language models and trying to do queries over the existing PDFs. And for example, let's say this PDF over here, you can already see there's at least 3 modalities of information. You have the text, then you have, pictures, which underlying these pictures is usually like maybe a table or even time series data, etc. And then you also have kind of graph-like data, the references. And having all this information is important when you're asking and trying to understand a document. I actually find it very, if you don't have this, imagine if you were just reading the text and you didn't have access to references, you didn't have access to figures. How are you going to make any sense of it? And I think this is a important piece of work because, literally, I would say right now, majority of the query, majority of the information is kind of lost in a lot of these documents that people are doing. So, yeah, tell us a little bit about your thoughts on, how much extra can we get through these multimodal models, and how much extra information are we missing out actually today with existing text-only based language models?
Yeah, so multimodality is a very important problem, very dear to my heart. I wrote my PhD thesis on the topic, and so I think it's very clearly the future of AI. And so, like you just showed, almost everything on the internet is multimodal. Our brains are extremely multimodal. How we experience reality is extremely multimodal. And if we want AI to understand humans better, then the more AI can experience the world in the same way that humans experience the world, the better AI will understand us. Like if you want to understand the meaning of the word cat, you can go to Wikipedia and look up and see that it's a small domesticated carnivorous mammal. Or you can go to YouTube and watch lots of cat videos, and then you'll understand it much better, right? I think if you're looking at the next generation, I mean, DALL-E 3 was just announced. The next generation of large language models are all going to be multimodal. Hugging Face recently did Idefix, and I think all the Gemini models, the GPT-4 is multimodal, although we haven't really seen it yet, but that's kind of coming out. So everything is going in that direction. And so there's the practical reason in that it unlocks a lot of new use cases. Like you can really think of like a construction worker just showing his phone around and saying like, hey, like, how should I like do this new thing? Like, how should I construct this new thing? And then his phone can just answer, like, you should be doing this first, but have you checked this other thing? So it's going to unlock a whole bunch of different use cases, but it's also particularly interesting because multimodality gives you a different view on the same underlying concepts. So that gives you reasons to believe that you can be more sample efficient. So like images are much higher bandwidth in a sense than words are, right? You can just have like a word that says like dog or something, but a picture of a dog has much more information in a way, right? So if you can use all of that information, then you can pump a lot more data through these foundation models. So there's this kind of complaint that exists where some people will seem to think that we're running out of data. It's like we're only just getting started, right? We're only just putting some text data through it and not even all of it. And like, imagine if we also put all videos and images and audio and everything all through the same model and allow it to synthesize these very complicated concepts.
Yeah, that's there's a lot of rumors out there that the Gemini model is exactly that. They're going to use all the data, including all the data in YouTube, and who knows, maybe even our our emails, who knows? But yeah, tell me a little bit, it's kind of, pictures are always 1,000 words. But what are other set of modalities of information do you think are going to be very useful other than pictures and text?
Yeah, so pictures, so pictures are just the visual modality without any sort of interaction, right? So video is actually gives you a much better understanding of visual reality than a picture does, where you can understand sort of causal effects in the same way that humans understand it, right? You understand this like concept of gravity, for example. You can't really learn that from looking at pictures, but you can learn it from looking at like things falling down in videos. So I think videos are a much richer modality in that sense. But yeah, every modality. I mean, there was recently some work again on olfactory things. So you can actually look at sort of the chemical receptors in for your olfactory or gustatory perception, so your taste and your smell, and even these you can handle with AI. So I have a paper from 2015 where we do olfactory semantics, and we show that if you want to have a very good vector space that approximates how humans experience similarity between certain concepts, you can actually build a bag of chemical compounds model. And then, so it's sort of like smell to vec back in the day. So that actually reflects human perception better than the word embeddings that we had at the time. And so I think that actually makes a lot of sense, because that's a very primitive area of your brain where a lot of these concepts are encoded in kind of a funny way, because you know that everybody else knows what things smell like, so you never have to talk about them. So an example I always like to give is like the smell of coffee.
Yes.
It's like, can you describe in words what coffee smells like?
Yes.
It's very hard, right? But so it's very hard because you've never had to do it, because you know that everybody knows what coffee smells like. So that also means that it's very hard to learn this from Wikipedia, because like, you know, you can go to the Wikipedia page and just look up like what is coffee, but it's not going to tell you what coffee smells like. So these kind of subtle things, or like common sense is what people sometimes call it. It's actually very important for how humans talk to each other. So if you want AI to really interact with humans in the same way humans interact with humans, then you want AI to really understand our world as best as it can.
That's talking about smell. I'm just putting a link over here. One of my coworkers at Google Research, they had done a startup called Osmo that uses AI to detect smells, and so we're going to be, the next version of DALL-E is probably going to be generating not just pictures, but nice olfactory smells related to those pictures.
Exactly. So. In like 2014, 2015, I was trying to convince my PhD supervisor, Stephen Clark at the time, saying like, we should just buy one of these like chemical compound detector machines and then just get lots of wine, because we were in Cambridge. So all the colleges, they all have their like wine cellars and things, and they drink a lot of wine at the high table. So then if we could just get a drop of all the wines and then try to predict the caption for the wine, so sort of the description, that could be an interesting project. But so he told me that wasn't a good idea.
A decade too early, maybe, but now it sounds like it's in the realm of possible. Okay, well, let's kind of like shift a little bit to a little bit more philosophical. So what do you think is the path to AGI?
Yeah, I don't like that question, to be honest.
Right,
I think this concept of AGI as a philosopher, I would say, is just completely ill-defined. But I think you can actually properly define it. And if you look at the OpenAI ethical charter, which was written by the people who are now at Anthropic, there's a very precise definition of AGI that they have in there. So it's something along the lines of when we get to a point where AI is going to be able to replace humans at most economically valuable work. So that's the point where we achieve AGI, so to say. So I like that, because it's much more concrete than sort of artificial consciousness, right? Which is what I think a lot of people take it to mean if they don't really know what they're talking about. But the problem there is this kind of qualifier of most. So like, what does most economically valuable work mean, and like, what does economically valuable even mean? So I think. Sort of forgetting about that sort of technicality, I think that we're actually pretty close to AGI in that sense. So we are very close to the point where AGI can do a lot of very valuable economic work for us. I don't think that necessarily means that humans are going to be displaced. It does mean that a lot of industries are going to be disrupted, but I think, as we've seen with previous technological revolutions, what's going to happen is that people are just going to sort of move up the technology chain. So like I was saying earlier on, I think everybody's going to be a CEO. and they get to command around this amazing AI company that does everything that they want to have. And so, but maybe I'm just being too hopeful here. But I really think that if we execute well on the potential of the technology, then we can just have this amazing productivity boom in the world where we're going to unlock all of this amazing stuff just because we have more time as humans to focus on the things that are actually important to us.
So we have a question that came in, and the question is, how soon after AGI do we expect to see ASI, which I guess is superintelligence, which is also probably very ill-defined?
Yeah, so and I like ASI as an abbreviation for artificial specialized intelligence. So we can also talk about that, because I actually think that for a lot of use cases, you don't need AGI. What you need is artificial specialized intelligence, where it's really, especially in enterprise settings, you just want to have a very narrow application domain, right? So you want the language model to like recommend a credit card or something. You don't want it to talk about quantum mechanics or Shakespeare or whatever. So I think that we're going to go back in a lot of these deployments to sort of smaller, more specialized use cases. And that means that we'll have different models there than sort of AGI models that can do everything. But to answer the question, I think if you get to AGI, so AGI is sort of ill-defined, but I think so if you define it the way OpenAI defines it, okay, fine. But then artificial superintelligence, I guess if you follow that same definition, means that it's not most but all. So yeah, I think that is pretty far away, where humans are basically completely useless.
Well, so do you have any thoughts on how we can make our AI ethical? Is there any?
Yes. Yeah, so I have lots of thoughts about that, but so I don't know if they really pertain to AGI necessarily. I think there are much more pertinent problems that we have to solve that are not really about AGI, but just about narrow applications of AI. So there are huge problems with AI not being deployed in a fair way, where we're very poorly doing a very poor job at evaluating these models, making sure that they're not biased. These systems really have the potential to have very complicated biases that are sort of exacerbated by how they're trained. And so as the more dependencies we start having on AI in our society, the more of these biases are going to exist everywhere. There are all kinds of ethical dilemmas around sort of the training data that goes into it, what safety really means, and whether politics has a place in safety. So if you look at a lot of the kind of alignment work, there are very strong political assumptions there about what is right, which are not necessarily right in themselves. There are very particular political worldview. So there are all kinds of questions there, and I think it's very important that we have social scientists and philosophers and people like that think about these problems together with the technologies who are building the technology, rather than sort of being obsessed with this idea of AGI and ASI and thinking that us technologies are the only people who can save the world. So I think that's a very dangerous worldview, where a bunch of sort of white tech bros in Silicon Valley get to determine the future of mankind.
And I think the work that you're doing with Retrieval Augmented Generation and having the answers of the AI be grounded in facts that we control, all right? When we actually can encode a lot of the knowledge in these systems explicitly. In some sense, the weights and biases, and after training, we can't control that at all. The machine just does what it does. But if we can control the information that we put on our knowledge bases, and we can also control how these large language models grounds itself in these facts as well. So I think the work that you're doing is critical towards ensuring ethical AI.
Yeah, I agree. So, but you could argue that. So, I really like the ideas around constitutional AI from Anthropic, where it's sort of a similar idea, where you have this constitution, and the language model always has to follow that constitution. But I think you're right that if you just put that into context, then it's basically going to be only implicitly encoded. So there are ways around it, or there are different biases that you might not be able to pick up on if they exist only in the context. Yeah.
All right, so we have a question on the multimodal topic. What can be done to enable AI to experience the quantum world such that it could give us useful answers that can't be observed as humans or is very expensive to discover?
Amazing question. I have no idea. So I guess that comes down to sort of having sensors for it, right? So right now, AI basically lives on the internet, and it doesn't have like an embodiment necessarily in the same way that we do. And I think if you want to have it discover the quantum world, then you probably need to embody it in the quantum world. And so I'm not kind of trained to know exactly what that would look like. But you are, Alan, so you probably know.
Yes. So I'm sharing a slide over here. Let's see if it's come up. So this is some of the work that I did at Google on TensorFlow Quantum. So the idea is, one of the very interesting ideas is, if you prepare the data on a quantum computer, one can use a quantum neural network to evaluate the data and look at the mixed, they call them mixed states, or the density function. And you can actually extract information from the, you can make these quantum computers experience the system. And then you can actually hook these up to a classical neural network as well. And so you can have information, you can almost imagine information that's classical going into the neural network, and then data that's quantum going into the quantum neural network, and merging those two together. And the very interesting thing is that one of the things that we did is that, well, this sounds all cool, but where's the speed up? Is there any real advantage? And actually, what happened was, okay, so yes, and I have this picture over here. We actually found that if you create your data, quantum data, and you use a quantum neural network on top of quantum data, you actually need exponentially less samples from the quantum data than you need from reading. You need exponentially less the quantum neural network required exponentially less samples than the classical neural network for decoding if something is in one state versus the other. So this is kind of getting at the cutting edge. So eventually we will see retrieval augmented generation, whereby the retriever is a quantum retriever, I suspect, and we'll be querying some sort of quantum database with mixed states using quantum sensors from all over the world, shoving this information in. But till then, we will be working on. There's enough classical multimodal information to make us happy.
Yeah, I think so. We have to wait for a grand unifying theory before we can actually do all of that. Right?
All right. Okay. So the last, I'm gonna keep the question about quantum computing to next time, and I'm gonna answer that offline. That might require a separate webinar, but why don't you just give some parting thoughts, especially to a lot of the people, especially the younger people who are just getting into AI, or people who are just getting into it. Tell us some thoughts and kind of advice on how to go about navigating this new world that we're in.
Yeah. So the advice I always like to give to people just starting in AI, but I think actually in general to people working in AI, is that it's still super early days. It doesn't feel that way when you look at all these big companies throwing like billions of dollars at language models and things like that. But there are so many open questions, and some of them are really basic ones, like, is the dollars per token sort of the right business model for an AI company? Like, we don't know if that's the case in the long term, right? So we are really only just getting started with this stuff. And so, I think it's really exciting times. I think you can think about sort of the Industrial Revolution as one big thing that happened, and sort of like steam engines, and then internal combustion engines, and the internet, and things like that. And so this AI revolution could make the internet revolution kind of pale in comparison. And basically, the only reason we invented the internet was so that we could get enough data to train very good AI systems. So that's only half joking, right? I mean, there's sort of a truth in that, I think, in the long term. The other piece of advice I think I would give in general is that a lot of people stay in their comfort zone for much too long. So I think what everyone should try to do is basically take risks in their life and always be outside of your comfort zone. If you're in your comfort zone, then you're not learning fast enough. So my parting message would be uncomfortable.
Well, thank you very much. This was a great presentation and get some philosophy from your team. So we hope to, when we hopefully we will put on the show notes a little bit about your company, and I would love to interact with you more on this journey.
Great. Yeah. Thanks for having me.
All right. Take care. Bye-bye.